The formula for magnetic force on a charged particle is F equals Q V cross B. Q is the charge of that particle in coulombs, V is the velocity of that particle in meters per second, and B is the strength of the magnetic field in Tesla. This formula uses a new kind of multiplication that you may or may not have seen before, called a cross product, represented by this X symbol right here. A cross product is a way that we can multiply two vectors together and get another vector. The magnitude of a cross product can be found by the following equation. If A is equal to B cross C, then the magnitude of A is equal to the magnitude of B times the magnitude of C times the sine of the angle between them. This formula may look familiar because it looks a lot like the formula for a dot product. There are two main differences between a dot product and a cross product. First is that for a dot product, it's A, B, C times the cosine of the angle between them. This means that if these two vectors are parallel, that means they're pointed in the same direction, which means the angle between them is 0. The dot product will be the product of their magnitudes. But the cross product will be 0 because sine of 0 is 0. On the other hand, if B and C are perpendicular to each other, that means that theta is 90 degrees. Their dot product will be 0, but the cross product will have a magnitude equal to the product of their magnitudes. Now, the second difference between a dot product and a cross product is that the result of a cross product is another vector, which means direction is important. There are two ways we can find the direction. The first is the method known as the right-hand rule. To use the right-hand rule, hold up your hand like in this picture. Your thumb points in the direction that the particle is moving. Your fingers point in the direction of the magnetic field, and your palm is facing the direction of force. The mnemonic that I like to use is that your thumb is like when you're hitchhiking, you stick out your thumb pointed in the direction you want to go. Magnetic field is usually represented by a bunch of lines. Those lines are your fingers. And you push with your hand, so that is the direction of force. Now, one thing to note, that force is equal to Q times V cross B, and Q can be negative. You can have a negative charge. If the charge is negative, then that means that the direction of force is the opposite of what you would get from the right-hand rule. Now, there is a second way to calculate both the magnitude and the direction of a cross product. It looks a little scary. I'm going to try to walk you through this. We start with A equals B cross C. Now, A, B, and C are all vectors. B is composed of Bi I hat, Bj j hat, Bk k hat, and similar with C. We can find the components of A by saying that the I component of A, right here, is Bjck minus Bkcj. The j hat is Bkci minus Bick, and the k hat is Bicj minus Bjci. Now let's try that another way. Let's instead look at the unit vectors and see how they multiply. That's a little simpler. I times j is k, j times k is I, k times I is j. However, cross product is not commutative, which means you cannot switch the orders of these two and get the same answer. In fact, if you switch their order, you get the opposite result. I times j is k, j times I is negative k times j is negative I times k is negative j. And because switching the answer should give you the opposite, or switching the input should give you the opposite answer, I times I is 0. J times j is 0, k times k is 0. Perhaps a simpler way of remembering this is to write down the letters ijk. And you know that if you're going to the right, it's positive. So I times j is k, j times k is I, k times I is j. And if you're going to the left, it's negative. K times j is negative I, j times I is negative k, I times k is negative j.